Hello everyone. As we learned from the column separation, if we record the detect response as a function of time, we will obtain a chromatogram. In this video, we will learn the information that can be obtained from the chromatogram. The first information is about time. As you can see from this chromatogram, there are three different times labeled. TR, which is labeled on the second peak, is called retention time. Retention time tells how much a species needs to travel through the column. You may be wondering why Tm is labeled on the first peak. The first peak on the chromatogram often associates with the mobile phase. This retention time is called Tm, which shows the time needed for the mobile phase to travel through the column. Sometimes some species may not interact with the column at all. As a result, they will not be retained by the column. Their traveling time is completely identical to the mobile phase ones. Another way to understand this is to consider this time as the time that the species spends in the mobile phase. The difference between TR and Tm is Ts, which is termed as adjusted retention time. Removing the mobile phase time from the overall retention time will give us the time that the species spends in the station phase. The second information we can read from the chromatogram is related to the magnitude of the peak. Statistically and analytically, the peak width is defined as the distance between the two intercepts of tangent lines and the baseline, and the peak height is defined as the difference between the signal maximum and the baseline. The third information requires us to do some calculations. Look at the chromatogram on the left. All 6 components are very well separated. If we are to quantitatively describe the efficiency of this separation, we will use plate number and plate height. The greater the plate number, the smaller the plate height, and the higher the separation efficiency. Mathematically, plate number is defined as n equals 16 times the square of TR over W, while the plate height is given by h equals L divided by n, where L is the color length. The last information is about separation between two peaks, separation resolution R. Shown here is the separation scenarios with different resolutions. When the resolution equals 0.5, the two bands, blue and red, are barely separated. When the resolution becomes 1, two bands are separated on the top, but the bases overlap. When the resolution equals 1.5, these two are very well separated. Therefore, ideally, the resolution for all separations should be greater than 1.5. Thanks for watching.